Right, lesson 106, kind of a lengthy chapter, so we've got this. I've got this split into two videos. This particular video, I want to talk about box fill. Okay, so in other words, how many wires can I jam into a device box and still be within code requirements, right? And they give you some very specific rules and things to know here. So, first thing we need to look at, first of all, we're going to check NEC 314.16b, and the textbook does a nice job of actually giving us this nice chart. The NEC doesn't put it in these nice bulleted lists. It kind of writes it out in a narrative form. But this chart does a really great job of grabbing those and turning them into some nice bullet points. And I'm only going to focus on the more common ones that we see quite often. So basically, this is going to tell us we need to add a certain amount of volume allowances, right? So essentially, count how many, quote unquote wires we have, right? Or for now, just think of it like a multiplier, right? So if we have a clamp, right? An internal cable clamp in the box, we're going to count a single volume based on the largest conductor in the box. So if I have one internal cable clamp, if I have 2, 3, 4, doesn't matter how many, one or more, I'm just going to count a single volume based on the largest conductor in the box. And we'll go through a full example. I think this whole volume allowance will make a little more sense when we see it all the way through. So next one I want to touch on is we have a device or equipment. So a receptacle, a switch. They tell us we're going to count a double volume for each yoke based on the largest conductor connected to a device on that yoke. What that means is yoke is basically meaning a single gang space, right? So a switch or a receptacle, that's one yoke. Yoke just means sort of like the mounting piece that mounts it into a single gang box, or a single gang space in a box. So a double volume for each based on the largest conductor connected to the device. So what's the largest conductor connected to the device? Count that twice. So if a number 12 is the largest conductor, you're going to count 2 volume allowances for number 12. Again, more when we see the example here. Next up, if we have an equipment grounding conductor in the box, which we always will, we're going to add a single volume based on the largest equipment grounding conductor in the box. Doesn't matter how many grounds you have in the box, we're just going to count the biggest one time. Okay. And if we have an isolated ground, we have to count that separately. That's not something we're going to see in any of our examples here, right? So another one they mentioned here, for any conductor that originated outside the box and terminates inside the box. So basically a wire that started somewhere else and ends up in this box. Guess what? Essentially we have to count that, right? Count that wire for what it is. One volume allowance based on the size of that wire. And then the last one I specifically want to talk about is for small fittings like lock nuts, bushings, wire connectors. We don't have to do anything at all, right? We don't have to count those. That doesn't mean you shouldn't consider them. Okay, we know a large gray wire nut or blue wire nuts can actually take up a lot of space. By code, we don't have to consider that. Another thing I want to mention, for your devices, for instance, I know that a GFCI is much bigger than a 15 amp switch. But by code, I can treat them the same. Doesn't mean I don't want to make some special considerations and say, you know what, I got a GFI in here, I better leave some extra space. Again, the code is the minimum. Doesn't mean you can't go beyond it, right? So, a little bit more on volume allowances. So essentially, for every volume allowance of any particular wire size, I need to include this many cubic inches in my calculation. Again, we'll do an example, it'll all come together. But the common ones, a 14 gauge wire, that counts as 2 cubic inches. A 12 gauge wire counts as 2.25 cubic inches. Keep those in the back of your head. It'll speed up your calculation without having to reference this table every time. But whatever size wire, for every volume allowance, you have to add this many cubic inches, right? So let's do an example here. All right, so in this case, every single wire in the box is number 12. I have a 12.2 coming in here, I have a 12.3 here, and a 12.3 here. Of course, then all my grounds are going to be number 12s. All my wires connected to this receptacle are also going to be number 12s. Okay, so the first thing I like to do is I'm just going to count my conductors. Now remember, we're going to count grounds separately. So we're not going to count grounds yet. We're just going to count hots, neutrals, switch legs, current carrying conductors, right? They originate outside the box, terminate inside the box. So let's go ahead and just count them. I like to keep sort of a tally of all of my volume allowances for any one size. So I have 1 number 12, 2, 3, 4, 5 number 12, 6, 7, 8 number 12s. That's wires that originated outside the box, terminated inside the box, not including grounds. We're going to count those later, right? So I have 8 of those. So let's go ahead next and go ahead and count our grounds, right? And what is the code tells us? We need to count one volume allowance based on the largest ground in the box. So it doesn't matter that we have 1, 2, 3 different grounds in this box. We're only going to count one volume allowance based on the largest ground, which is a number 12. Again, everything's 12 in this particular box. Okay. Next thing I want to hit is let's do the device itself, right? The equipment on a yoke, that kind of talk. So basically a receptacle or a switch. If we remember, I have to count a double volume allowance based on the largest conductor connected to it. Largest conductor connected to this receptacle is a number 12. So I'm going to count a double number 12. 1, 2, bringing me up to 11 total, right? The only other thing we might want to think about is a cable clamp. But remember, that was for an internal cable clamp. These are all external cable clamps. So at this point, we don't really have anything else we need to count. We don't have to count wire nuts, as we remember. We don't really have to count ground screws, lock nuts. So we've got everything accounted for at this point, right? So what do we do now? We have 11 volume allowances for a number 12. That's great. So let's go ahead and check our table 314.16b. Remember, that's the table that tells us how many cubic inches per volume allowance we need to include. So for number 12, we need to include 2.25 cubic inches, right? So I'm going to go ahead and multiply my 11 volume allowances by 2.25. Of course, that gives me 24.75, and that should say cubic inches, not square inches, but 24.75 cubic inches, right? So that's well and good. What do we do with that information? We haven't really talked about that yet. That's where we have to reference 314.16a, right? Many boxes, they will give you the total allowable cubic inches will be printed somewhere right on the box. Other boxes you can actually go ahead and calculate, but the NEC actually gives us this table that tells us the total the minimum volume within that box, or the maximum volume of wires we can put in there in inches squared, right? I just want to talk about what each category is because it's not really the most commonsensical thing. So if we talk about a round or octagonal box, that's what we have, right? I think that one's pretty easy to imagine. And notice they give us 4 by 1 1/4. So 4, since this box is pretty symmetrical, is this dimension, right? 4 this way, 4 this way. The second number here is actually the depth. Okay, how deep is the box? And since this is round or octagonal, they don't give us, both of these dimensions because we understand they're the same. Same story with our 4 by 1 1/4, 1 1/2, 2 1/8. That's a 4 square box. So we understand it's 4 by 4, and then the second number is our depth. Same story down here with the 4 11/16. It literally is 4 11/16. Why they settled on that dimension, I don't know. People are going to call that a 4 11 box quite often. The biggest way you can tell, because just look at these pictures, there's no scale. How can you tell 4 square versus 4 11? Biggest difference is on a 4 square, your screws are going to be in the corner. On a 4 11, they are not. They're going to be sort of on the side, right? Now this next one is a device box, a 3 by 2, and then the depth. But what's the difference between this 4 by 2 1/8 and then the depth here, right? So notice, of course, this one's a little smaller, 3-inch. Let's just go ahead and skip ahead to the 4-inch here. Notice, these are a little bigger. What's the difference? These screws are for mounting your device. So these screws are the same distance apart. Notice on the bigger size here, they're inside the box. On the smaller size, they're outside the box. So notice, naturally that box is smaller than this box. Okay, so that's how you can tell. This would be known as a handy box. This one's known as an old work box or a cut-in box. But that's how you can kind of make a quick reference and tell the difference. And then we get into a masonry box. These are known because they're basically usually squared off. These are going to be going in a block wall or a brick wall. But again, they have a specific dimension. And then we have our weatherproof boxes. The big difference, the FS and SD, is you're going to have a single gang or double gang is what they're talking about here, right? And there's your double gang. So, let's take a look here. So we calculated 24.75. Where does that fit? What box can we put that in? Well, let's go down through it. We can't fit it in any of these round boxes. Can't fit it in that one, but we could fit it in this 4 by 2 1/8. And that's kind of a standard box, and the reason they go by the 2 1/8 rather than the 1.5 inch, naturally that's a big jump right there. We could get it in any of these 4 and 11 boxes. That's no problem. Of course, we have problems with I think the rest of these boxes. We're not going to work with any of those. So we got a lot of stuff in there. So anyway, you can see this would be a tight fit in most any box. So we do need to sort of be aware of what we're doing here. Let's look at one more example. In this case, we're going to have different sized wires. So a little bit of curveball. So we have a 14-3 coming in here, a 12-2 coming in here. The 14 gauge connects to the switch. The 12 gauge connects to the receptacle, right? So let's now we're going to have to keep track of 14 separately from 12. So let's just count all of our 14 gauge wires that originate outside the box. We're not going to count grounds, right? So we have 1, 2, 3. Good. Now let's go ahead and actually count our switch. Since those 14 gauges are connected to the switch, let's go ahead and count that guy. So we have a double volume allowance, right? So there's 4 and 5 based on the largest conductor connected to it. Okay. I'm not going to count this 14 ground because remember for the grounds we only count the largest ground in the box, and we actually have some number 12s in there. So we're not going to count the 14s at this point. So I think we've got all of our 14 wires counted. So jumping on to 12, let's count the conductors that originate outside the box, not including grounds. We have 1, we have 2. Okay. Let's go ahead next and count the device, the wires connected to that receptacle. Remember, a double volume based on the largest conductor connected to it, which is a 12. So we're going to count 3 and 4 for number 12s connected to the device. Then we do have to count our ground. In this case, the largest ground in the box is the 12. We're going to take a single volume based on our number 12. So that gives us 5 number 12s. And this is a new piece. We actually now have some internal cable clamps up here, right? Now, they should have taken this cable clamp out of the box since it's not used. Doesn't really matter for box fill. We need to take a single volume based on the largest conductor in the box for a cable clamp, period. Doesn't matter if we have 1, 2, or 10. The code tells us we need to take single volume, right? So there we're going to add one more, giving us 6 number 12s. All right, so at this point, I think we've got everything totaled. So let's go ahead and look back. How many 14s do we have? We have 5. How many number 12s do we have? We actually have 6. Again, let's reference 314.16b. We can see that for a 14, we need to multiply by 2 cubic inches. For a 12, we need to go by 2.25. So we go ahead and do that. We come up with 10 cubic inches for our number 14s and 13.5 cubic inches for our number 12s. Okay, so we now actually have to add those together because all of that volume allowance is in that box, right? So when we go ahead and do that, we get 23.5. Then again, it should be cubic inches, not square inches. But we could then take that back to that box sizing chart and decide, are we using a big enough box? One thing to mention, as you can see here, they have a mud ring or a tile ring on this plate. A lot of times those tile rings are raised, or maybe you have an extension ring. All of those items should be marked with a depth or actually a cubic inch measurement. Go ahead and add that in as well. We can use that to our favor, right? So again, there's your box fill.